We're here today at Ablana Photonics, a Dublin-based laser technology company that is working with the European Space Agency to develop the world's most accurate clocks. These atomic clocks will fly on board the next generation of European satellites, the Galileo system. And today I'm talking to the company founder, Dr. James O'Gorman. James, what are atomic clocks and how do they differ from other ordinary clocks that people might be familiar with?
Well, Sean, in the past, the second was defined in terms of being a fraction of a year. And that's not a very reproducible thing. It's not something that you can easily compare. So you need something that's something physical that you can measure. And one way of doing this is by measuring the frequency at which an atom vibrates. And that is what an atomic clock does. It measures the frequency of vibration of an atom, and it compares all of the things that you use for measuring time. For example, there might be in your watch a little crystal that's used to measure time that ultimately is referenced back to the second that's defined by an atomic clock.
These atomic clocks are going to fly aboard the next generation of European satellites. Why do we need such accurate clocks on these satellites?
Well, the reason is that, as you know, today sat-nav systems and in general GPS systems have become very, very widespread. Everybody uses them for driving, for ships, for airplanes, those types of things. And the way this works is that your sat-nav system essentially is as a timekeeping. It's basically an accurate clock. So what happens is that the more accurate the clock signal that it gets from the satellite that it's measuring from, then the more accurately it knows where exactly it is, which means that when you're driving along the motorway, if you have a more accurate clock that's beaming the signal at you, ultimately you know better where you are. You won't miss that turn to the right.
That's an American system originally. So why is it important that we have our own system here in Europe?
Well, one reason is that it's important for the European users to have an independent system where they're not dependent upon other entities to provide their timing systems to them. But more importantly, things like most airplanes or jets at this stage are guided by these navigational type systems. It's important if you're on a plane, I think you'd be more comfortable if you knew that you had an always-on system and that you had a redundant satellite system that was capable of providing clocking to you in a situation where one of the other satellite systems developed a problem or whatever.
You're a laser company primarily, but you're working with very, very small lasers. Nothing like the ones we might have seen in the James Bond film.
Oh, they're very small. They're smaller than a grain of salt, in fact. They're made on relatively large wafers, which would have a diameter of 4 inches, if I'm still allowed to say 4 inches. And they're made with conventional semiconductor manufacturing. But generally, we make lasers for 3 applications. One would be for high-speed fiber optic communications. This gives you more high-speed broadband, so you can download movies in effectively real time into your home. We use them in sensors, both for measuring strains in different items or in medical applications. And we also use these sensors or use our lasers in these clocking type systems where you're looking for particular attributes that our lasers deliver better than anybody else's laser.
So fiber optics, we're obviously talking about light. We're moving from point A to point B very, very quickly. You're looking to try and get this into every home in Ireland.
That's correct. And that enables applications like downloading videos, downloading movies very, very rapidly. You probably remember in the past that you'd be driving down a country road and you'd see a cable strung from pole to pole. Well, all of those cables essentially were carrying copper wire, and over the years they've replaced all those with glass fiber because it means you've got higher speed communications between the towns. Now what's happening is that's all dropping down a layer to a point where that glass is now being deployed between the central switches or the post offices and the end user, which means that the end user begins to get the benefit of those high bandwidth connections. So what you will see in a situation where people are getting full access to fiber to the home is that their bandwidth will increase by a factor of 100 to 1,000. And what that means is that you can download a video, a movie in a couple of minutes. It also means that if you want to have a conversation with somebody, that you can basically have a large high-definition screen where you're talking to the individual and without any corruption in the quality of the video image that you currently see if you're on a broadband connection that has got a high contention ratio.
These extremely accurate clocks then that are being developed here in Dublin, when are they likely to fly in space?
Well, these are very long projects. Generally, from the concept to the completion of that project, you could be looking at 10 years, maybe somewhat more. The Space Agency at the moment is launching what's called Galileo 1, where this type of clock will potentially go into is what would be called Galileo 2.